So continuing the last lesson in which we were looking at multiplying and dividing with rational expressions, here I want to look at adding and subtracting, the first of two lessons. And the reason I'm going to spend two lessons on this is it goes back to the simple fact that, in general, adding and subtracting fractions quite often requires more steps in terms of calculating than multiplying or dividing. Just for example, if I had 1/2 plus 1/3 versus 1/2 times 1/3, unless you already know in advance what the answer is, this multiplying is just 1/6. Multiply the numerators, multiply the denominators. That's it. If we want to add your fractions or subtract, we need to first find a common denominator. And so it's not a lot of work in this case, but the lowest common denominator is a 6. Make them both a 6. So instead of 1/2, I have 3/6. Instead of 1/3, I have 2/6. And once I have the common denominator, then I can add it, and it's really quite quick. But because of that, it took more work just to add those two simple fractions, and so that's why it's going to take, generally, more work to add or subtract rational expressions. That's assuming the denominators are different, which in this first example, they're not. If the two denominators are already exactly the same, then just like 1/2 plus 1/2 is 2/2, or 1/2. In this case, 2x over x plus 4 plus 8 over x plus 4 is still going to be the same as 2x plus 8 over x plus 4. That's it. As usual, we should check and see if we can simplify this, put this in lowest terms. In this case, the numerator, I can take a factor of 2 out of the numerator. And then, I can simplify this. I have a factor of x plus 4 that I can cleanly cancel out of both the numerator and the denominator, which leaves me with just 2 for my answer. So that whole original expression, 2x over x plus 4 plus 8 over x plus 4, is the same as 2. And in fact, no matter what number you pick for x, if you substitute any number you want for x and you follow all these calculations, you will get 2 unless there's a restriction. And there is a restriction. X cannot equal -4. And I can see that in the very first step here. And so it's 2 as long as x does not equal -4. If you pick any number you want except -4 and substitute all the x's in this expression here with any number you want, I guarantee if you do your calculations correctly, you'll get 2. But if you pick -4, you don't get anything because you'll be dividing by 0 at some point. Well, that wasn't so bad because we had the same denominator. Here we have different denominators, but it's pretty straightforward to find the same denominator. Look at my 3 different denominators. I want to find the lowest common denominator, and that will be 6. So I'm going to change these all to a 6. And so again, just that basic idea, to go from 2 to 6, I multiplied the denominator by 3, so I need to multiply the numerator by 3. And so it becomes 9x. And to go from 3 to 6, write this in a different color, I multiply my denominator by 2, so I need to multiply my numerator by 2, so it becomes 2x. And then I don't have to do anything else after that. And so my numerator is going to be 9x plus 2x minus 5x, which, put that all together, is 6x over a denominator of 6. Those 6's cancel out, it reduces down to just x. Now, are there any restrictions? No, there's no restrictions, because if you look at my expression, I know it's kind of messy right now, but there's no variables in the denominator. I don't care what number we pick for x, we will never be dividing by 0, which literally means you can pick absolutely any number you want, put it into this original equation, especially if I'll erase all these markings I did. Pick literally any number you want for x, put into this expression, calculate everything, you'll always end up with the exact same number you started with. That's what that's telling us. And there's no restrictions. All right, so let's look at this pair. Okay, so getting a bit more, but again, I'm trying to avoid doing too much intricate stuff today, because again, we have 2 sort of parts to this lesson, so let's focus on this. One thing you may notice right away that I can do is I can cancel out an x from here to here, which kind of cleans up that one expression right away. However, in my experience, quite often we We may not notice that right away, but if you can reduce something right away, I would. So then what I have here now is just 2 over y plus 4 over x squared. Okay, that's it. I need to find a common denominator. If I look at here, right now my two denominators are totally different, which means I need to multiply this side by x squared, the numerator and the denominator. I need to multiply this by y. And again, if it seems kind of strange, it's really no different than if I have 1/5 plus 1/7. If I want to find a common denominator, in the end I'll make them both 35. But in doing that, I'm multiplying this side by 7. I'm multiplying this side by 5 to get to that 35. So I know it may feel different, but it's fundamentally the same idea. And so what I have now is a common denominator of x squared times y in my denominator. In my numerator, what do I have? I have 2x squared plus 4y. All right, and so now I should just see if I can simplify this at all. I can take a factor of 2 out of the numerator. If I do that, I get x squared plus 2y. But I still don't see any factors that cancel out. Yes, you may be drawn to the fact there's an x squared here and an x squared here, but in the numerator, that's not a factor. It's x squared plus 2y. It's not just x squared. There are no common factors that I can cancel out. And so we're done here, aside from the restrictions, and the restrictions are that x cannot equal 0 and y cannot equal 0. And honestly, I'll circle the step before it as well. That was, I factored the 2 out of the numerator, but didn't do anything with it, so they're both good. Let's look at this, 1 plus 1 over x. Well, I want to find a common denominator, and right now I can make any whole value look like a fraction by showing it being divided by 1, which means I can find a common denominator if I multiply this and this both by x. And don't have to do anything to the other, to 1 over x. So I have a common denominator of x, and in my numerator I have x plus 1. Or x times 1, but just x plus. Sorry, I have that was confusing what I just said. Right here I have x plus x times 1, but might as well just write it as x. And again, I should see if I can simplify anything here, but again, I cannot. I don't have a common factor of x in the numerator or in the denominator. I have a factor of x plus 1 in the numerator, but not just an x. So I can't cancel anything out. So I've simplified it. My restriction is x cannot equal 0. All right, so last pair before final problem. Look at these two. And so let's focus on the expression on the left. I want to find a common denominator, and I want to make this 1 have a denominator. There we go. And so I can see the lowest common denominator will be 12. So I'm going to change this to a 12, which means I'm multiplying the denominator by 4, so multiply the numerator by 4. I'm going to change this to a 12, which means I'm multiplying the denominator by 3, which means I want to multiply all of this by 3. And change that 1 to a 12, which means I want to change the top to a 12. Okay, it's gotten pretty messy. I got to be careful. In the numerator, I have 4 times x plus 1 minus 3 times x minus 2 plus 12. I have all that in my numerator. So let's be careful with that. But my denominator is nice. It's just 12. Okay, so now let's clean this up. I can distribute this negative 3 here. I can distribute this 4 right here. So notice I get not minus 3x plus 6, because it's minus 3 times minus 2 plus 12. And now it's a matter of combining like terms. And if I combine like terms in my numerator, I have 4x minus 3x, which is just x. And I have plus 4 plus 6 plus 12, altogether is 22, positive 22. And all that's over 12. There's no common factor. And there's also no variable in my denominator, so there's no restriction. So that's my answer. X can be anything. There's no restriction to be stated here. by far the most common place you could make a mistake is right here. And forgetting that that should become a positive 6, not a minus 6. All right, let's look at this one. Hopefully you immediately notice we have a common denominator already, so this actually will be pretty pleasant. My numerator, just x squared plus 3x minus 10 over my denominator of x minus 2. However, I should see if this can simplify, and I can't really tell until I try factoring the numerator. And it factors quite quickly because of two numbers that multiply to negative 10 but add to 3. Those two numbers are negative 2 and positive 5, which means my factors are x minus 2 and x plus 5. And yeah, this does simplify. I can cancel out a factor of x minus 2. So in the end, this is the same as just x plus 5. All of that stuff in the end is behaves same as x plus 5. Is there a restriction? Hopefully you know there is. I can see right from the very first step that if x equals 2, I'm dividing by 0. And so I should have a little restriction here. X cannot equal 2. Now I'm done. And so to be honest, everything we've done today has been rather quick because I've been avoiding denominators that are a bit more challenging. But still, these are these fundamental ideas of this lesson. So at this point, all that's really left is a final problem that really leads into the second half of this lesson, which is the next video. And so how would you approach something like this? Okay, so while I'll do this, questions like this are really more the focus of the next half of this lesson. And so how do you find the sum of this? How could we add these two fractions? We don't have a common denominator. How do you find a common denominator with stuff like this? Well, hopefully what comes to us fairly quickly is realizing factoring at some point tends to be useful. And so let's factor that y squared minus 4. It's a difference of squares. So why is that helpful? Well, if I look at this now, if I look at my two denominators, they already have a factor of y plus 2 in common. That's good. The more they have in common, the better. So they already have that in common. So to find ways so they have everything in common, all I need to do is multiply this expression on the right by y minus 2 in the numerator and the denominator. Because now notice, the two expressions have the exact same denominator of y minus 2 times y plus 2. And so what do I have in the numerators? I have y squared minus 20 plus y minus 2 times y minus 2. Or y minus 2 squared. OK, so now at this point, if something is going to cancel out, and now don't be tempted to cancel out a y minus 2 here, because I have a factor of y minus 2 in the denominator. I do not have a factor of that, at least yet, in the numerator. That y minus 2 there is not a factor, because its factors are when everything is being multiplied to each other. But there's this subtraction and subtraction here. But why just this part right here? Y minus 2 squared. I can expand and simplify that quickly. And hopefully, really quickly, I can go to y squared minus 4y plus 4. Using the principles we've seen lately of dealing with perfect square trinomials. And I have over here y squared minus 20 minus all that. OK, let's distribute this negative or get rid of these brackets, however you want to look at it. So I've got to be careful. A lot of negatives I'm dealing with here. That's it. I do have some like terms here. For example, well, actually, hold on here. Oh, you know what? I made a mistake. And maybe you caught this mistake. But for some reason, and I don't know why, right here, I took this perfectly pleasant plus sign and made it subtraction. Why did I do that? I have no idea. The good thing is it's easy to fix, and it'll actually make my work a bit simpler because I have less negatives. But yeah, I just willed there to be a negative subtraction sign there that doesn't belong. And so I'm sure you may have noticed that. But let's go back and fix that. That for no reason I changed it to a minus, and I have no idea why I did that. So there we go. That's plus, which means that's a positive, which means I'm not really distributing anything here. I'm just getting rid of the brackets, which means I don't have to change any signs. That's a bit nicer. So sorry about that. But at this point now, I have some like terms. Y squared plus y squared is 2y squared. I have some like terms here. Minus 20 and plus 4 is negative 16. And so I'll write it in a fairly standard order. My numerator is 2y squared minus 4y minus 16 over these same two factors that have been here for a while down here. Okay, can I simplify this? Well, I don't really know until I can factor, but can I factor the numerator? I can take a factor of 2 out of the numerator. If I take a factor of 2 out of the numerator, I'm left with y squared minus 2y minus 8. Right, looking from here to here, I just took a factor of 2 out. Still nothing's canceling out, but can I factor this part right here, the y squared minus 2y minus 8? Yes, I can, because there are two numbers that multiply to negative 8 and add to negative 2. Negative 4 and positive 2, which means, lucky you, there's more to do. So that part in green can be factored into y minus 4 and y plus 2. And so yes, there is a common factor, after all, that does cancel out. And so now cancel that out and cancel that out. I can simplify this down to 2 times y minus 4, or 2y minus 8, over y minus 2. And if I just go back to the restrictions, I can see r just cannot equal plus or minus 2 all along, nothing else. Yeah, so y cannot equal plus or minus 2. All right, so notice, in this case, you know what? That was a lot of steps. And why was it so many steps? Because we had to find a common denominator. To find a common denominator, it was helpful first to factor. And then, yeah, we had a fair amount of steps to combine some like terms. I made a mistake and changed a sign for no good reason, but at least I caught that. And then in the end, when we simplified our numerator and factored the numerator, there was indeed a common factor we could cancel out. So this, this had a lot of steps. Although I will say, this one problem connects to just about every single concept we've looked at so far in the last 5 or 6 lessons. Aside from multiplying, dividing fractions, it kind of connects to everything. So yeah, it was a tough problem. But mostly just based on our work from Math 10, work with polynomials of factoring and distributing and foiling and all that stuff. But these sort of questions will become more the focus of the next lesson. So let's stop it here.